So my name is Anat Reiner, and I'm a statistician and a data scientist in a Rambam hospital. It's for those of you who don't know, Rambam is the largest hospital in the north. It's one of the 3 largest hospitals in Israel. And I'm going to talk about a project we're doing that is aimed to structure free text from medical reports for malignancy. The reports are pathological reports, results of tests that are being done under the microscope and in yielding written reports, free text written reports, and we want to structure them in order to make the data accessible for research, reporting, and anything else that you can do with data. So I'm going to first introduce the concept of a pathological report, a short, very short medical information, medical introduction. We'll show some free text and how does the report look like and what is the value of the database that we can create from such reports. And then, of course, I'm going to extend about the project itself for structuring the report's free text data, prepare gold standard data, first of all, and then to structure the data using an NLP analysis by using an NLP-based model. So a pathological examination is the standard for diagnosis and treatment of malignancy. It's performed in a hospital, in the lab, following a biopsy or a surgery. For example, in the case of breast cancer, we perform a needle biopsy and extract small part of the tissue from the suspected region and then put it under the microscope and see what's in there. And also following a surgery where we might remove a lump. This is called lumpectomy. Or actually, if we have to remove the full breast, it's called mastectomy. Then we take the tissue again under the microscope and check what's in there. So if we go on with the breast cancer example, so how does breast cancer diagnosis goes? A woman undergoes a mammography screening test, and then in a case there's a suspicious lump. This is the picture here. We will send her to biopsy check where we enter with a needle and extract a small sample of the tissue. We sort of color this tissue so we can see the cells and put it under a very strong microscope. This is what it looks like. And an expert physician in the field of pathology called a pathologist examines the tissue under the microscope, and from whatever they can find there, they prepare a report of the pathological findings that contains free text. So what do we want to see in the report? What is interesting in the report? So first of all, the descriptions of the cells. This would what is called the histological type. And actually describes the type of cancer if there is cancer there. The cancer, for example, could be in situ carcinoma or invasive carcinoma. We also want to know the stage of the disease, how much it extended already. What is the grading of the cell division, the cell differentiation? How far did it go? If we took out a lump by surgery, we cut the lump out and we want to make sure that there's nothing left in the margins of the cut. So we look at the margins and see whether there are any remains there. We also classify the cancer into in situ local cancer or cancer that already invaded other tissues around it. This is invasive cancer. We want to check also the lymph node involvement. This is where we look for metastasis. And we want to check the tumor for biomarkers. Biomarkers can help design our precision treatment that increases the probability for a response from the patient. So this is what a report looks like, basically. It's just written text, several parts, the material, the tissue that got into the microscope, a macroscopy check, which is what the doctor can see in his eyes, with his eyes, and the microscopy description, which is what is being seen under the microscope. Why is it free text, actually? Why can't the physician enter the data into a structured system? Well, this is impractical. Physicians are in a hurry all the time. They're overloaded with work, and it's inefficient just to go field by field and put the data there. So we are stuck with these written reports at the moment. The free text includes a lot of characteristics and details from the test, and the more sophisticated the treatments are, the more data and more information we need to describe the test, the results. The data contained misspellings, abbreviations, professional jargons, a lot of terminologies that are special to this domain. Combination of Hebrew and English, because still physicians mostly write in Hebrew, but they use a lot of terms in English. And of course, there is the personal style of the physician. Each pathologist would write it in a different way, in different style. Some would be very punctual and precise and short, and some would just tell stories that are very extended with descriptions. So, for instance, the important sentences that we can see in the microscopy. Forgive me for all the non-Hebrew speakers, cannot understand, but I will read a little bit of Hebrew here, just to emphasize what is important. So in the microscopy region of the test, we see a gush afor lavan nukshe. This is a description of what it feels like, this suspicious region. Begodel 2.2 כפול 2, this is the size of the tumor and the units of the sizes. In the microscopy check, we see the קטע רקמת שד עם invasive duct carcinoma. This is the histological type, the type of cancer. It's grade 2, and again, the size. הגידול נמצא במרחק של פחות מ-0.1 סנטימטר. This is concerning the margins, and more information that is related to the type of cancer, the size, the distance from the margins, and invasion, and additional details. So if we had a pathological report database, structured database, we could enter it into the EMR, the electronic medical records of the hospital, and just use it for many purposes. First of all, improving patient care by monitoring and quality control of the data, and just passing feedback to the physician. R&D on personalized medicine, diagnostic tools, prognostics and response predictions that we can do on the data. And reporting, of course, for cancer registries and biobanks that is being done today, but in a very limited scope and only on a small number of parameters that are required by the government. Much more global contributions could be to enable, for example, anonymization of the data, if we're able to structure it, and thereby sharing the data with other institutions and other researchers for R&D purposes. And of course, support the development of what is nowadays called digital pathology, where some companies develop image analysis of the slides to replace some of the work of the pathologist. And they need data and annotated data of high quality to do that. So we have a lot of motivation to start this project for structuring free text pathological reports. And I'm going to describe this project a little bit. So the objective is to develop a system that automatically structures free text reports and immediately once entered into the hospital database. So the system will read the report text, convert the text to acceptable fields using NLP analysis, and then embed the information in the rest of the hospital database with all the clinical information that we have, and make it an accessible information. In this project, we focus on malignancies of breast, lung, and colon. 35% of new cancer cases in the US are from these three cancers, and 40% of cancer deaths are due to these cancers. Also, there have been found many biomarkers related to these cancers for treatment decision, and there are existing national screening and intervention programs for this cancer, so it's worth investing in database for these cancers. The task that we have here are, first of all, to prepare the gold standard data from which we can develop a model, and then develop the NLP-based model that will structure the data automatically next time a report comes. And for preparing gold standard data, we need to extract the reports of all the reports that we're interested in and define the variables or the entities in NLP jargon to extract from the text. As you've seen, the histological type, the grading, the lymph nodes, every type of information, but in the form of entities. And then we might want to rank them and to give them weights so we can construct a smart evaluation system for the later on model. We need to do the annotation of the data. This is probably the hardest task to begin with for labeling and tagging. So we constructed a user interface system to do that. We started with breast cancer. We have around 10,000 documents or reports from this cancer from year 2000 and on. We got into all kind of technical issues with the data because some of the data was saved in PDF format and some were from older formats. We need to solve direction problems in the text due to Hebrew and English. Those of you that type all day in both Hebrew and English know that how much it can be messy with directions. And we also want to categorize the data and see what kind of reports we have. So there are all kinds of purposes for which a pathological test is being done, either for assessing the biomarkers of the tumor or the core biopsy itself, a lumpectomy where you remove the lump, lymph node analysis, etc. So this is the distribution of types of reports that we had. And then we want to design a UX system or user interface system for labeling and tagging the text. So we define all the variables or the entities not just according to what we see in the text, but actually with attached to professional codes from the pathology world. We use the CAP standards, the College of American Pathologists standards, SNOMED and ICDO codes, which are disease codes. We then build a user-friendly interface, which I will show soon. That is made for a manual annotation of the data. We actually hired several medical students in an advanced stage of their studies and trained them using the expert pathologist to understand this pathological report and to understand how to label and tag everything. So this is what this opening screen of the UX system for labeling and tagging looks like. On the right, you see the report itself with all the relevant information, and then you have several sections of the report that you can open and start inserting the data. So let's just show an example. Let's focus on the microscopy check. We want to label and tag this part. So we have here קטע רקמת שד עם invasive duct carcinoma. So invasive duct carcinoma belongs to the histological type field, and we just open a big menu here and put in the invasive histological type. Grade 2, we go to the field called grade, and we put a numeric value 2, and also copy, this is called the tagging, copy the grade 2 phrase from the free text into the screen here. And then we have this begodel, so we want to say which kind of measure we are using. So we choose here a size and copy the word godel, which is in Hebrew, it's a size, into the screen here, etc. And then we have the numbers. We have 2 dimensions, so we choose numerical values from the 2 dimensions and then copy the text just as is, this by this. So it will just give the system, the automatic system, an idea of what made us in the text decide that these are the sizes and what made us decide that this is the grade, etc. This is what the model will learn from. Okay, this is just another aspect of the margins, dealing with the margins of the lump. I will just skip it. So, of course, we do have, again, the challenges of NLP in such text. It's a unique professional language. It has unique phrasing and style. It is a specific corpus of terms, and for each medical domain, it's different. If we go, for example, for the lung cancer, you will see a whole different world of terminologies. Some of them are the same, of course. We have the Hebrew issue here. We'll discuss it in a little bit. And this is not a very big corpus. Actually, when you divide it into types of cancers, you will have only thousands of reports to deal with. So, the Hebrew issues. We have a mix of Hebrew and English English words in Hebrew forms. This is just a habit of either Israelis or Israeli physicians or both. For example, we want to say gidul polshani, but we will say invasivi, gidul invasivi for invasive. And this repeats itself a lot. So they just make up new words in Hebrew, which are not real words. We have here vascularim, irregularim, introductali, preparat. These are all words in English. But this is how physicians speak. And we also have unique professional terms in Hebrew. Balutot zakif, glilei rekmat or, biopsat ekdach. These are all words that we're not using in our everyday life. So we just have this corpus to take them from. גושונים, גלילי רקמה מסוננים, okay, specific terms. So the NLP analysis is facing these challenges. Its objective here is to extract the information in a unified format, okay, to turn all the varieties of one concept into just one unified concept. And the assignments are well-known NLP assignments, named entity recognition. You want to match the text to the right entity. For example, match gidul invasivi into the entity invasive histological type. The more complicated mission is the relation extraction. You want to match the text into its actual meaning. For example, מרחק לשוליים לטרלי מעל 2 סנטימטר. You want to match it into lateral distance greater than 2 centimeters. Okay, and this has many varieties of how to write the same things. The existing helpful NLP tools that we have is, for example, the YAP system, which is a linguistic analysis software in Hebrew, which you can find morphemes and lemmas from a given sentence. We have dictionaries that we can construct and use for the model. We have the Python NLP packages, the Spacey for tokenization and segmentation from a sentence, the GenSim library, which can help in word and phrase frequencies. The PigTry library that helps using dictionaries by searching tests for dictionary terms. And we're trying to make use of all these. We constructed dictionaries suitable to our world of terminologies, a Hebrew and English dictionary that matches each raw term into its unified form at the end, and also gives the right entity. So you can use a pretty simple rule-based system to learn a model from these dictionaries. Same for a Hebrew and English dictionary that we prepared, and more complicated dictionary for histological type that is sort of hierarchical definitions from the CAP codes of the pathologists. Developing an NLP-based model would involve first the model training, where we use one way is to use the dictionaries and linguistic analysis using YAP, for instance, and then try machine learning-based models and deep learning transfer models if we can join some data from other sources. Model validation will use all the acceptable ways of measuring performance, of course, sensitivity, specificity, F-score, predictive values, etc. And then I forgot to translate this into English. This is validation by physicians. This is what we add to the usual model development procedure when we want to take the results given by the model and give them to the physician so they will compare it with their own judgment. We have some, I will show some results from the rule-based dictionary model. For example, 2 assignments that we wanted to do here is identification of the right entity. For example, invasive histological type. So we have here a pretty high precision and recall relatively. But when we want to identify a specific entity, for instance, both invasive histological type, but also specifically the value, invasive micropapillary carcinoma from a specific ICD-10 code, this is more challenging for a dictionary-based model, and we have not as good performance. So the next steps that we're working on is, first of all, we can refine the dictionaries, and we're doing them. We can add the use of regular expression to enable generalizations that do not depend on specific words. We can use suitable models for NLP, for machine learning, and we are aiming also to incorporate deep learning technologies if we can find additional similar Hebrew texts from other sources, and can then maybe use transfer learning and make it usable for pathology projects. And I will just say what kind of functions you need to participate in such product. We have the medical team that is just guiding us to do things right. In terms of medicine, we have pathologists, oncologists, and epidemiologists participating. We have the medical students that are really working hard on the annotations. We have the R&D team, NLP experts, statistician, data scientist, that's me, the UX developer, the production developer, and the project manager. And we have the Innovation Authority that is the financing part of the project. We have the Rambam Research Authority and the Rambam MedTech company, which is the IP transfer company of Rambam. That's it. This is a short introduction for this project, and I hope to report further results next time. So thanks a lot.